In this video, I'll be talking about ocean sustainability. Sustaining ocean life goes beyond preserving fish species. The process of restoring the ocean can help reduce poverty, increase food sources in coastal areas, and provide income. Earth's largest bodies of water are vital to and are some of the best indicators of the planet's health. Based on their current conditions, things aren't looking so good. Humans have polluted the ocean to dangerous levels with offshore drilling, cargo transport, and trash. One garbage truck of plastic is dumped into the ocean every minute, amounting to over 8 million metric tons of plastic annually. In addition, with the climate change happening every day, it is forcing fishes to move to different locations. But artificial intelligence is already coming to the rescue. To sustain ocean life, researchers are combining artificial intelligence with robotic technologies for efficient monitoring in places humans cannot go. Water covers as much as 70% of the Earth's surface, yet 95% of the ocean remains unmapped. One example is an autonomous floating garbage truck powered by artificial intelligence that helps clean up the Great Pacific Garbage Patch. Let's watch a video to see how the autonomous floating garbage truck works.
1.8 trillion pieces of plastic float at the surface of the Great Pacific Garbage Patch. Here, the ocean cleanup is deploying the world's first technological solution to this growing problem. The principle behind it is simple. Create a coastline where there are none. Concentrate the plastic and take it out. The system consists of a 600-meter-long floater and a 3-meter deep skirt attached below. The floater provides buoyancy to the system and prevents plastic from flowing over it, while the skirt prevents smaller particles from escaping underneath. As the impenetrable skirt creates a downward flow, marine life can safely pass beneath it. Here is how the system catches plastic. The system takes advantage of 3 natural oceanic forces: winds, waves, and currents. Both the plastic and system are being carried by the current. However, wind and waves propel the system only, as the floater partly sticks above the surface, while plastic is primarily just beneath it. The system thus moves faster than the plastic, allowing the plastic to be captured. The skirt extends deeper in the middle of the system than on the outer edges. As the current applies pressure on the skirt, the system naturally adopts a U-shape, which enables it to concentrate plastic in its center, like a funnel. The drag generated by the skirt also acts as a stabilizing force, allowing the system to reorient itself when the wind changes direction. And because the system, like the plastic, is free-floating, it automatically drifts to the areas with the highest plastic concentration. Fitted with solar-powered lights, anti-collision systems, cameras, sensors, and satellite antennas, the system actively communicates its position at all times and continuously gathers performance data. Periodically, a support vessel comes by to take out the concentrated plastic, like a garbage truck of the ocean. The plastic is then transported to land, recycled, and made into durable products. This is the first of a fleet of 60 systems. Once deployed, the fleet is expected to clean up 50% of the Great Pacific Garbage Patch every 5 years.
In other oceans, machine learning is making it possible to follow marine litter in real time, enabling responses that are quick, targeted, and more effective. The monitoring and predictive technology of machine learning can also help researchers understand the human actions and subsequent changing conditions that harm the ocean, such as coral bleaching, illegal fishing, disease outbreak, and industrial activity. There are many phytoplanktons in the sea. It's vital to keep them alive because they are critical to sustaining ocean levels. Currently, the scientists use satellite imagery to monitor the microalgae, but a new satellite technology will be launched in 2022. The technique named PACE for Pre-Aerosol Clouds and Ocean Ecosystem will not only control phytoplankton, but the different species of microalgae that also affect the environment. Scientists can monitor larger marine life and animals with AI and robotic tech. The Murdoch University in Western Australia is implementing drone technology to monitor dugongs, a mammal similar to manatee but with a forked tail. Researchers will fly over the ocean and count the dugongs, but now they can send drones to capture thousands of images instead of using aircraft. Although they are saving money and time on flight, the collection of big data is too large to analyze in a reasonable time. So Dr. Frederick Murray from Queensland University of Technology developed an AI program that automatically detects the animal's images from the drone images. Murray can adapt the program to search for images for other animals, such as whales and sharks. It has an 80% accuracy rate and will continue to improve as scientists train the program. Combining AI and robotic technology can reduce illegal activity by poachers through tracking, as well as reduce emissions from cargo ships by suggesting the best routes. Another environmental challenge that we are facing is the urgent need to clean up and stabilize drinking water. The planet is running out of fresh water, and much of what's left is dangerously polluted. Across the world, 1.8 billion people are currently use a water source contaminated with waste, according to the United Nations. Not only will a healthy ocean benefit its inhabitants, but the entire human race as well. Thus, AI is the next step in helping us reduce and improve our planet one step at a time.